Hello everyone, welcome you all once again to this online session. In today's class, we'll be continuing with this chapter, that is chapter number 9, Force and Laws of Motion. In the previous class, you have already learned the definition of force, balanced and unbalanced forces and all. Let me do a quick recap of this and then we'll proceed further. See, force, the push or a pull on an object is said to be force. We need to apply force in order to set an object which is at rest to the state of motion, in order to bring an object which is already in state of motion to the state of rest, in order to change the direction of motion, in order to increase or decrease the speed of a moving object, right? So applied force brings a change in the direction of motion, in the position, in the speed of motion of the object. This is what we have learned. Okay. Now this force is mainly of two types, that is balanced and unbalanced force. What is balanced force? When the force acting from two opposite directions are equal in magnitude, we call that force as balanced force. Unbalanced force can be defined as a force acting from two opposite ends, unequal in magnitude. Simple example, in the game of tug of war, if both the teams standing on two opposite ends of the string are of equal strength and stamina, then they cannot win the game of tug of war, because the force acting on it is a balanced force. The forces acting on the object is equal in magnitude, though they are opposite in direction. If one team is weaker than the other team, then they can easily win the game, because here the forces are unequal in magnitude from two opposite directions. So unbalanced force brings about a change in the position of the object, or unbalanced force help us to do any kind of work. Okay, so balanced force cannot set a stationary object into motion. It cannot change the direction. It cannot bring about a change in the speed of the moving object, whereas it can change the shape of an object. Whereas unbalanced force can help you to change the position, change the direction of motion of the object, bring about a change in the speed of the moving object. So unbalanced force help us to do any kind of work. So we need this kind of force to do our day-to-day activities, like you're playing, swimming, pushing, pulling, stretching. For all these activities you need to apply force, and in order to do any kind of work, the applied force should be unbalanced. So learn three things here. Definition of a force: the push or pull acting on an object is said to be force. When the applied force from two opposite ends are equal in magnitude, we call that force as balanced force. When the force acting from two opposite ends are unequal in magnitude, we call that as unbalanced force. And unbalanced force can only help us to change the position of the object, direction of motion of the object, can bring about a change in the speed of the object. Balanced force can bring about a change in the shape, but it can never set a stationary object into motion. Clear? Now let's get into today's topic, that is Newton's first law of motion. Before that, I wanted you to learn about this Galileo's experiment, which paved way for Newton's first law of motion. See, in this three figures are given. In figure A, you can find a marble rolling down an inclined plane. In figure B, you can find a marble climbing up an inclined plane. And figure C shows a marble resting on an ideal frictionless plane inclined on both sides. Again, I am telling you, figure A shows a marble rolling down an inclined plane. Figure B shows a marble climbing up an inclined plane. Figure C shows a marble resting. Just look at there. It is resting on an ideal frictionless plane inclined on both sides. Right? So from the conclusions given by Galileo's experiment, Newton's first law of motion was developed. Now let's learn the conclusions of this Galileo's experiment. Okay. See, what did Galileo do? Actually, he had kept inclined surfaces on two ends, and he started rolling down a marble from a height on the left side, and the marble started rolling down with an increase in its velocity, and then it climbed up on the inclined surface kept on the opposite side. When it was climbing up, the velocity was found to decrease, and in order to reach the same height from where it was dropped on the opposite side, it has to travel a long distance. Then he observed by changing the angle of the inclined surface on the right side. He started reducing the angle of the inclined surface on the right side, and on the left side he kept the height same. Then he rolled down the marble. When it was climbing up, though the velocity was found to reduce, but it reached that same height by traveling a long distance. Then he made the angle of the inclined surface to be 0. In that case, he found the marble rolling with a constant velocity to reach the same height from where it was dropped by traveling a longer distance. So from this, he concluded that an unbalanced force is essential only to change the motion of an object, whereas no unbalanced force is needed to keep an object moving with a constant velocity. So whenever a body is moving along a straight line path, will continue its motion in that same straight line path in the same speed unless it is acted upon by an external force. Clear to you? So this base given by Galileo helped Newton to develop his 3 laws of motion. So from this experiment, Newton had given his first law of motion, which is also called as law of inertia. It states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. So in order to set an object into motion, you need to apply an unbalanced force. Otherwise, the object is going to continue its state of rest. So the first law of motion states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless it is acted upon by an external unbalanced force. Clear? So this law is also known as law of inertia. We will see few more examples, then you will understand the law better. See, first we'll see the examples and then I'll tell you the meaning of inertia. Inertia can be stated as the tendency to resist the change. Okay, just see these examples. See, when a car is suddenly started, the passengers in it fall backward. This you must have experienced in your day-to-day life. When you are sitting inside a bus which is about to start its movement. When it gets started, you all will get a jerk in the backward direction. Why? Because your body was at rest when the object was at rest. When the bus or the car was not moving, your body was at rest. When the object is set into motion, your body has to set itself to move along with the motion of the object. So it is resisting that change. It cannot accept that immediately. So you are experiencing a backward jerk. So when a bus or a car starts suddenly, you get a jerk in the backward direction. because your body is not willing to accept the change. This tendency is what is called as inertia. When you are inside a moving car or a bus, when it stops suddenly, you will experience a forward movement, means you will fall forward. This also you must have come across in your day-to-day life. When a moving bus or a moving car stops suddenly, you will fall in the forward direction. Why? The bus or the car which was in motion, at that time your body was also set into motion along with the motion of the object. So when the object is suddenly brought to rest, your body is not willing to accept that change. So you are showing a forward fall, stating that you were also in motion along with the motion of the bus. So this tendency is what is called as inertia. The fruits or leaves fall down when the branches of tree are shaken, sudden change happening to it. Whenever you want to dust a carpet or a bed at home with a stick, what happens? The carpet starts moving, but the dust particles in it remain there only due to inertia. It will not accept the change. Then you have to repeatedly beat the carpet so that the dust particles begin to move. One more example, whenever you try to get down from a moving vehicle, your body cannot come to a standstill position immediately. You will be moving in the direction of the bus or the car. This you must have seen in your local trains. Some people, before the train stops, they will try to get down on the platform. At that time, you cannot find them standing erect. They will also move. Though they had get down, they will start moving in the direction of the train, and then only they will stop. An athlete, after reaching the final point, you cannot find him come to a standstill position immediately. He will run because due to this property of inertia, his body cannot immediately come to the state of rest. Or when you are adding bonvita or cocoa powder or sugar into your milk, you stir it continuously. Even if you stop stirring, you can find the swirling of milk. That is also due to inertia. You have added sugar or cocoa powder or your bonvita into the milk and you are stirring it continuously. So when you stop, the swirling of milk also should stop, but it does not happen because of inertia. So inertia can be defined as the tendency to resist change. So these are the few activities listed in your book to explain about your first law of motion. See here, in a glass you have to fill some water, and then you have to place a small cardboard. On that you have to place a coin. When you strike the cardboard, you can find the coin dropping down into the glass. The cardboard is set into motion, but this coin is at rest on the cardboard. Due to inertia, it falls into the glass. Your carom board coins, before you make them move along the board, what happens? It falls, it gets scattered, right? A ball which is at rest will continue its state of rest unless and until you kick or any other external force like wind acts on it in order to set into motion. Okay, these are the examples of Newton's first law of motion. So an object which is at rest will continue its state of rest, or an object which is in motion will continue its state of motion unless and until an external force acts on it. Okay. See, all the examples and activities that were shown till now states that there is a resistance offered by an object to change its state of motion. If it is at rest, it tends to remain at rest. If it is moving, it tends to keep moving. This property of an object is called as inertia. And the best example, the movement of the blades of the fan. When you turn off the switch, you can still find the blades of the fan moving around. This is because of inertia. Okay. So the inertia of an object is normally measured by its mass. So we can relate this inertia and mass in the following way. Like, this inertia is the natural tendency of an object to resist a change in its state of motion or of rest. The mass of an object is a measure of its inertia. For example, the coin which was placed on the cardboard above that glass tumbler. If it was going to be an 1 rupee coin, you have to apply less force. If it's going to be a 5 rupee coin, you have to apply more force. So normally when the mass increases, the force applied on it also should increase in order to set into motion. So this mass of an object is a measure of its inertia. The greater the mass, the more is going to be its inertia. Clear? So inertia is the tendency to resist, not willing to accept the change immediately. Movement of the blades of the fan even after the power supply is cut off. A passenger's forward fall when the bus stops suddenly, backward jerk when the bus or the car starts suddenly, swirling of milk even after you stop stirring. These are all your day-to-day examples to make you understand the concept of inertia, which is also called as Newton's first law of motion. This inertia is again can be classified into three types: inertia of motion, inertia of rest, inertia of direction. Inertia of rest means what? A body which is at rest will continue its state of rest unless and until an external force acts on it. Example, dusting a carpet. As I told you, the dust particles on the carpet will be in the state of rest. When you constantly or when you repeatedly keep beating on the carpet, then the dust particles try to fly out. Okay, inertia of motion. An object which is in motion will continue its state of motion unless and until an external force acts on it. Your athlete, after reaching the final point also, he'll continue to move. The blades of the fan, as I told you, when you put off the power supply, the blades of the fan doesn't come to a still position. It continues its state of motion. Inertia of direction. An object moving in a particular direction will continue to move in the same direction unless and until an external force acts on it. A passenger getting down from a moving bus or a moving train will continue to move in the direction of the movement of the bus or the vehicle. Right? So these are the examples. Okay. So what we have learned today? We have learned that force is required to put a stationary object into motion or to stop a moving object. First law of motion states that an object continues to be in its state of rest or of uniform motion along a straight line unless acted upon by an unbalanced force. The natural tendency of object to resist a change in the state of rest or of uniform motion is called inertia. The mass of an object is a measure of its inertia. So its SI unit is said to be kilogram. Force of friction always opposes motion of objects. Okay. So we'll meet you very soon with the next topic. Until then, take care. Keep revising. Bye.